This is topic 4.9, help redox reactions. This is to help with your Thanksgiving packet. I hope you all had a nice Thanksgiving, but we still have work to do. Assign oxidation numbers to all of the atoms in the following. So we have CrO42 minus, and then we also have K2Cr2O7. So if we have an ion that has a charge on it, that means our oxidation numbers have to add up to that. So we see we have CrO42 minus. That means our oxidation numbers need to equal to that. So if you have oxygen, most likely it's going to be 2 minus. So that means if my O is going to be 2 minus, minus 2, however you want to say it. So minus 2 times 4 is negative 8. So if that has to equal 2 minus, that means that my CR has to be plus 6. We have potassium dichromate. So that means that there's no charges. So that means they have to equal 0. So if we have oxygen the way it is, like I see it, so it's going to be times 2. So this negative 2 times 7, this has to equal 0 somehow. So if the O is negative 2, I have potassium, automatically it's going to be 1. So 1 times 2. So what does my CR equal? So it's going to be kind of 2 plus, 2x plus type of thing. So I have, see, 2 negative 14. So this is going to be, hold on, I'm just talking out loud. So 2x minus 14 plus 2. So this is 12. That means my CR is going to equal plus 6. So those are my oxidation numbers for potassium dichromate. Identify the elements that are being oxidized or reduced in the following reaction. So if it's oxidized, that means it's losing electrons. If it's reduced, that means it's gaining electrons. So we have PbO plus CO producing solid lead plus carbon dioxide gas. So whenever you see an element by itself, like a metal by itself especially, this means this is going to be 0. Okay, so we have PbO2, so this is right here, that is going to be minus 2. That means lead has to be plus 2. Here, this is minus 2. That means my carbon has to be plus 2. I look at my CO2. If this is going to be minus 2 times 2, that means that my carbon here has to be 4. So you can kind of, 4 plus, I'm sorry. So you can kind of figure out what's happening here. So if we're going from, let's see, my lead, you notice the things that we're kind of focused on are, I guess, maybe things that are not hydrogen or oxygen, maybe. So we have lead, Pb, going from plus 2 to 0. And then we have carbon going from plus 2 to plus 4. So for it to have to go from, for it to go to plus 2 to 0, remember that if you have a plus 2 charge, that means you lost 2 electrons. If you have plus 2, I'm sorry, you lost 2 electrons. So for you to go back to 0, that means you had to have gained electrons. So that means that lead is reduced. Carbon, you notice that it goes from plus 2 to plus 4. That means, remember we said plus 2, that means you lost 2. Plus 4 means you lost 4. So that means that it lost electrons. So this one is oxidized. So lead was reduced, carbon was oxidized. Not sponsored by Mario or Nintendo or anything like that. Balanced using the standard redox method. You have copper plus HNO3 plus hydrogen ions or protons producing Cu2 plus nitrogen monoxide and H2O. So we have to look and see what is reduced and oxidized. Okay. So we have copper going to copper 2 plus. So you'll notice that a lot of our examples that we've had, you see metals gaining or losing electrons. So that's going to be your clue. Might want to look for those. Hydrogen and oxygen, those are helpful. You need to know those oxidation numbers because you'll notice here, for example, you have the nitric acid and nitrogen monoxide. Knowing your oxygen oxidation numbers and hydrogen oxidation numbers can give you the nitrogen oxidation numbers, which are going to change as you go from left to right. So for example, we have copper, so Cu by itself is 0. It's going to plus 2. Okay, let's try a different color. Let's see, so I have minus 2. Oops, it's supposed to be a different color. Minus 2 plus 1. That means that my n here has to be plus 5. And then I'm going to go to the other side over here, to this other nitrogen. So if this oxygen is 2 minus, or minus 2, this one has to be plus 2. Let's do some other colors here. So hydrogen, 1 plus. This is going to be plus 1 and then 2 minus. But like I said, let's focus on the nitrogen and the copper. So we can see that the copper went from copper to copper 2 plus. That means for it to go from left to right, my copper, the solid copper, had to have lost 2 electrons. So it's going to be copper 2 plus 2 electrons that are kind of floating around, if you will. Conversely, I have my nitrogen. You can say it's nitrogen here. What the heck? Sorry. That's a plus 5 oxidation number. You have to go from 5 plus to nitrogen with a plus 2 on it. You have to add 3 electrons. So from left to right, I gained 3 electrons for it to go from the plus 5 to plus 2. So that means that my nitrogen, in case you need to know, my nitrogen was reduced, and then my copper was oxidized. So when you're combining, or you're balancing, you have to cancel out your electrons. So how do you do that? You have to multiply by a number for each, and that's going to make the number of electrons the same. Okay, so that means that my top one, I multiply all of that by 3. Then my bottom one, I multiplied all of that by 2. And what does that end up happening? Let me use a different color, green. So when I combine the two, I end up with, well, not really combining it, but what I'm going to do is I have 3 copper, 3 Cu2 plus 6 electrons. On the bottom, I'm going to have 6 electrons plus 3N producing, Sorry, 3n. Sorry, 2n. Oops. Producing 2n over here, 2 plus, and this is 5 plus, just so we're clear on what's happening. Now my electrons cancel out. So I'm going to add those, but I cannot forget about the H plus and the H2O that I had earlier. Wow, that's confusing, isn't it? So the way that these are written out, I'm just going to kind of put in these coefficients back into the original spot. So I'll do another one, another color, so you can see that. So it's going to be 3Cu plus. Sorry, my bad. That's wrong. Erase that. So I'm going to do it this way. So 3Cu plus 2HNO3 plus my H plus. I will balance that out afterwards. Then I have 3Cu2 plus 2NO and then my H2O. But I got to make sure that I'm balanced, which I'm not. So let me see what we got to do, what I have here. So I have 6 O's on the left side. On the right side, I have 2 times, so I got 2 from the NO, then I have 1 from the H2O. If I put a 4 on my H2O, I need myself some more space. I'm going to have 6 O's on both sides. Now I got to fix my H at the front. So I'm going to put a 6 in front of the H plus, so now I have 8 H's on both sides. And that's how you balance this using the redox method. So if you have any questions, please let me know. I'm going to box this in so you can kind of see it. Hope I don't make a mess. And I did make a mess. All right, if you have any questions, please let me know. Remember, I'm not sponsored by Nintendo or Mario or anything like that. So if you have any questions, let me know. Hit that like and subscribe. Thanks.